nanomaterials is a science that will and is revolutionizing the way we interact with the world.
Therefore, gold has been recently studied in order to discover what are its properties. And one of the most useful properties that have been found is that it is very useful to turn air polluted particles into non-polluted particles. And this is
Although air pollution contributes to many health problems, it is not confronted as it should be. As government thinks, it is too expensive and counterproductive to implement measures due to economic restraints.
Air purification basically consists of the oxidation of the different pollutants that can be found in air, as for example CO2, CO, and ammonia.
Before involving ourselves in the question that resides in our minds, what properties allow this element to be so efficient, we should see first its origins, as everything has a beginning. The study of this type of catalyst was first made by Masatake Haruta, who currently owns an enterprise with the same name focused on the use of gold support catalysts. It was in 1982 when Haruta discovered that catalysts containing gold obtain high catalytic activity for the oxidation of H2 and CO at room temperature and low temperature, respectively. Nonetheless, we have to ask ourselves, how did Haruta develop these catalysts?
To understand this, we have to remember that extended surface area created with gold nanoparticles are very useful as a catalyst. Gold is well known as a material that doesn't activate molecular oxygen. In this case, what we care about is in the nanostructure of gold. If there is more available area in the gold surface, more molecules will be able to interact with it. Gold clusters are a set of atoms that are arranged in different ways. In gold clusters between 10 to 42 nanoparticles, the ones that have 10, 128, 20 have very high symmetry. We can see that different types of gold have different charges and gold-gold bond length values, which affects the particle's wave function. The length of those bonds and the surface charge that are around. When a surface has similar catalytic activity is because the bond length and charge distribution are unified. It is important to remember that the oxygen activation is approximated by the length of the oxygen-oxygen bond and the charge transfer from the nanoparticle to the oxygen molecule.
Why are gold nanoparticles such good catalysts? A possible option may be the application of gold catalysts, making use of their superior activity in oxidation of CO and hydrocarbons at low temperatures. Gold nanoparticles are highly effective catalysts due to its oxidation properties at relatively low temperatures, which makes its use more feasible. Based on growth of the number of papers and patents dealing with gold-based catalysts for a range of potential applications in pollution control, chemical processes, and development of fuel cells, it can be concluded that there might be a bright future for gold-based catalysts. Gold nanoparticles as good catalysts can be described by two of its properties: the high reactivity that they have and the low temperature at which they react.
Using gold nanoparticles is convenient because they offer a wide variety of benefits in different areas, such as medicinal, electronics, catalysts, and others that can have an impact on different industrial uses. The use of these nanoparticles has been increasing over the years, and it is expected that this nanotechnology can reach the reach of different companies to make efficient use of these nanoparticles. Gold nanoparticles find applications in industries such as a chemical catalyst, which is very important since these catalysts are very good removers of air and water pollution. Being able to work with these catalysts is very beneficial for the environment and for the companies that use it. Nowadays, a group led by project Professor Toru Murayama from Tokyo Metropolitan University and partners from NBC Meshtech have designed a filter that can function at room temperature. This brings benefits for the environment and for the company, since being able to work with a catalyst at room temperature prevents the manufacture and use of machines that activate the catalyst, since very low temperatures are needed to be able to work with this application of nanoparticles of gold. Once this prototype is developed, a technological and industrial breakthrough will be seen.